Hi, hello and welcome to the channel Fix Your Mercedes. If any of my videos helped you repair your car, then please hit the button super thanks. And if you want to be the first one to watch my video as it is fully uploaded, then hit the button join. Thanks. Well, at first, sorry. Sorry for not publishing videos for such a long time, but I'm really super busy. Busy working on one car, and something I wanted also is to apologize for that live video yesterday. I thought I could do this video without editing it, but it turned out to be that I don't know how to do a live video with my phone. It was upside down, the picture, the video, and it drove me crazy. That's why I erased the video. So now I will have to do it this way. As you have seen from the title, we're going to be talking about the duty cycle. Do you really have to buy an expensive multimeter that can measure duty cycle? What is actually the duty cycle? Well, if you ask me, it's nothing. It's some formula, something made in percentage, something that is fictional, that does not exist like as a unit or something. For example, if we take 1 liter, 1 liter, we're talking about volume now, is actually 1 cubic decimeter. So if you make any container that is going to be 1 decimeter in length, 1 in width, and 1 in height, you will be able to pour exactly 1 liter of any liquid. If you don't believe me, try it and you will see that. Then let's speak about feet. What is a foot? For example, as a unit, 1 foot equals 30 centimeters, and that's how you calculate 5 feet, 10 feet, and so on. Furthermore, we say 1 ton. 1 ton is 1,000 kilograms. So that's also something that exists. It's not called 1,000 kilos, it's 1 ton, 1 mile, 1.6 kilometers. And now, again, to get back on the liters. If we have 3.8 liters, that's 1 gallon US. And 4.5 liters is 1 gallon UK. So that's everything that can be definable. And now let's talk about oscillations, about frequency, about Hertz. 1 Hertz is 1 oscillation per second. The moment you say 1001, that's 1 Hertz per minute. So that's 1001, 1002, 1003, That's a Hertz, which I'm going to demonstrate you now. Here, let me show you what it actually means, 1 oscillation per second. If we have 1 oscillation per second, that means we have 60 per minute. So let me just calibrate it. And here is our metronome. This is 1 Hertz, 1001, 1001, 1002, 1003, 1004. If you want 2 Hertz per minute, per second, sorry, so that's 120 per minute. 1001, 1002, 1003, 1004. So that's 2 Hertz. 2 oscillations per second. And now, and so on. For example, 3 of them. It's approximately this much. That's 3 Hertz. Four Hertz, approximately this much. It was some scientist that had a second name Hertz, and he defined these oscillations, this unit, according to his second name. And that's how the same thing is for ampere. It was also scientist, and for volts, I think it's the same, but I don't want to go too far in and away from our actual topic. But when you say duty cycle, what is it, duty cycle? Nothing that can be defined. So let's see it right now, how it looks like. What we know about the duty cycle, that it's measured in a percentage. It consists of on and off time. What we have to get is ignition on, engine off, 70%. After starting the engine, the percentage drops to 30. Short afterwards, it rises to 50. And it stays that way. Once the engine is at the operating temperature, the percentage then starts fluctuating between 45 and 55%. And then we're all thrilled, hyped, and so on and so on. Everything is fine. The last thing we have to know is the higher the percentage, the leaner the mixture, and vice versa. So, if the duty cycle is some kind of a signal, it has its peak, and then it lasts for some time. So that's some voltage in some time. So we have voltage, US voltage, in certain period in milliseconds. So the on time is the time when the signal is present, and the off time is the time as the signal is absent. Right? And again and again. So, why did I take 70%? 70% means no RPM signal. That's something you're going to obtain because there are no rotations from the flywheel. The crankshaft position sensor cannot register any because the flywheel is not rotating, and therefore the camshaft is at a standstill. And of course, logically, because there is no signal, the car is off. So if no signal, the off time is 70%, then on time is 30%. 70 plus 30 makes 100. Right? And that's the full cycle, something completed 100%, right? So again, the duty cycle equals percentage. One full duty cycle is 100%. 70% out of these 100 is off time, no signal, and only 30% is on time. And that makes 100%. So if we want to define anyway the duty cycle, that is 30% out of something. Just 30%. And now, that was something fictional, something that does not exist. I can fully say like that. Let's now make a comparison to something that exists, and that would be voltage. Now, as we're able to measure the duty cycle on X11 by measuring percentage, we can also measure voltage. And we're going to take now the same graph. We're going to measure voltage within a certain period, within milliseconds. So then we have the signal on and then off, on, off. So let's now see. If 100% is the maximum, the peak of something, I will take that the peak voltage is 12%. Of course, the voltage in the car can be higher. It can be 13 volts, it can be 14, it can be more and more. But all the components that work in the car work on 12 volts. So now I'm going to take 12 volts because the ECU works on 12 volts. Now, if we take 100% and we then take 12%, 12 volts instead of 100%, and we divide by 3 we're going to get 4 volts. So the duty cycle, the on time is actually 4 volts. That's why I can state that 4 volts equals 30%. Now, as I want to get those 50%, to see how much it is in voltage, I will at first divide 4 to 30, and then I get 1.33 volts. So 10% equals 1.33 volts. As I want to get those 50%, then I again look at this. I state 10% equals 1.33 volts. Then 50% equals 5 times 1.33 volts, and that equals 6.65 volts. So now, to get those 5% plus minus, now I'm going to split on half 1.33 volts, and I get 0.65 volts. So the next task for me will be to know, of course, the higher the voltage, the richer the mixture, in contrast to percentage. So I add 0.65 volts to 6.65 volts, and I get 7.31 volts. So then the goal, this means for me that the goal for me is the fluctuation to get between 6.65 and 7.31 volts. It can be a bit higher, but not so much. So once you get this fluctuation on your car between 6.65 and 7.31, then you will get your mixture to be ideal. You'll make it to be ideal. Everything I'm talking about here, it's not just a talk. And this is my pattern. I can say it because maybe this is how I've been calculating the mixture and the duty cycle, and I didn't take for example the battery voltage as you start a car. It's over 13 volts. No, this is how I did it, and I don't just speak about this just like that. Here I'm going to post you the link here. This is the link to my Instagram page where I did the measurements on W126 560 SEL California version. That's the car from Mohammed Al-Baloshi from Qatar, who I greet now from all my heart. And I just wanted then to investigate. Once I got this fluctuation, I told him how to achieve that. I then wanted to measure the milliamps on the EHA. And what we got, it was the nominal value for the EHA. The nominal value for the EHA for 90, let's say it like that, 90% of all the cars is between -3 and 0 milliamps. Okay, it can be between -3 and +3 milliamps. but it goes like that with the EHA. The more the amperage goes in negative range, the richer the mixture, and vice versa. But as I got this voltage on X11, then I got this fluctuation on the EHA. So the purpose of this video was for you to show you that you actually do not need to buy any kind of expensive tools and multimeters. No, you can do this with a common multimeter, with the cheapest one possible, that can only measure DC. That's the goal. So digital current. It must be able to measure resistance, amperage, voltage, and if you want, you can have, for example, buzzer, and that's everything you need. And with that kind of a multimeter, you can set your duty cycle, your mixture on your car. Well, now it depends of you, how precise your hand is. You will have to literally turn the screw for 1/16 of a turn, then you wait about 10 seconds, then you press the accelerator, because then the ECU is in a learning mode. It learns, then you gave another parameters, and bit by bit, and that's how you can set your ideal mixture. Let's say duty cycle. And that would be everything for this video. So, if you liked this video,
please consider subscribing to our YouTube channel and click the bell to be notified when we post new videos.
Then I would kindly ask you not to hit the button skip ad. That is going to help me a lot. And till some next one, happy Mercedesing. Bye.